Thank you. Hello, everyone. Thanks for taking time and joining today's workshop on migrating to Amazon DocumentDB with MongoDB compatibility. My name is Meet Bagdev, and I'm a Senior Product Manager in DocumentDB. In this workshop, we will walk you through the different migration phases, talk about the various migration tools at your disposal, and go through a few demos to show you what the end-to-end experience looks like. Throughout the workshop, we will also answer any questions you may have, so feel free to chime in with questions. We'll take them as we get them. With that, let me pass it over to Jeff Duffy, who's our expert on all things migrations, and he'll walk you through the rest of the content today.
Yeah, thanks a lot, Meet. So hi, I'm Jeff Duffy. I'm the DocumentDB Specialist Solution Architect. And as Meet said, let's talk today a little bit about how to migrate to Amazon DocumentDB. So I'd like to start by pointing out that while the bulk of today's conversation is going to be about migrating specifically from MongoDB to DocumentDB, we do talk to a lot of customers who migrate from other data stores to DocumentDB, and I wanted to make the point that this was not only possible but not super uncommon. And so we have seen customers migrate from relational stores like Oracle or MySQL to DocumentDB, maybe because they've discovered that they really want the flexibility of a document model as opposed to the sort of column and row approach to modeling their data that they get with relational databases. Sometimes customers come from key value stores where they've discovered that they need the ability to index and ad hoc query a little more deeply into their data, and so they want to query nested attributes maybe, which you can't do with traditional key value stores. Of course, other document stores I talked about like Mongo, and occasionally we see customers coming from maybe Couchbase as an example of something where they've decided that they want to have a more fully managed solution and migrate from there. And then finally, we do see customers migrate from Elasticsearch to DocumentDB, primarily in use cases where they've discovered that the main thing they want to do with the data is not use it as a search engine, but basically have a document store as a system of record. So when we're thinking about migrating to DocumentDB, we want to think about our migration in 4 primary phases, starting with the discovery phase. And this is the phase where you're going to better understand what it is you're migrating from. What kind of deployments do you have locally? What does your data look like? What do you need to think about in terms of compatibility and so forth? So the second step is going to be planning. In the planning phase, this is where we're going to discover, how we need to migrate. What considerations do I need to think about, and what potential, considerations need to go into making sure that I have a successful migration. So then, of course, we're going to have the testing phase, and this is, maybe just as important as everything else, making sure that you're actually doing testing with the workload that's representative of what it is that you want to move to production. And then finally, executing your migration, actually getting your data onto DocumentDB so you can use it. And you'll see at the bottom here that we have a migration guide that I'll bring up later in my browser, where everything that I'm talking about today is also available to you within our docs. So in the discovery phase, we really have 3 primary objectives, and they are to verify the compatibility with DocumentDB. So if you're coming from a Mongo source, DocumentDB is not a drop-in replacement for Mongo, and while we have support for the vast majority of features that customers want to use, it's important to understand which features we do and don't support so you go into your migration fully educated. We want to get the inputs for a sizing and costing exercise. Of course, if you're migrating to any data store, and especially a managed database like DocumentDB, you want to understand what potentially your monthly bill is going to look like. And of course, you're going to need to know what your sizing needs to be in order to get that estimate. And then finally, you want to think about what your migration options are. As we'll talk about in a little bit, there are a number of different ways to migrate to DocumentDB, and which ones may serve you best depend in part on what you're going to discover about your local implementation. So when we're thinking about verifying compatibility with DocumentDB, of course, first we need to think about the version that we're coming from. And you can run a command like db version to show you what you need to do, to reveal what version you're running. So DocumentDB is compatible with the MongoDB 3.6 API. And so what this means is in a bit when we talk about the different migration options, one of them uses the AWS Database Migration Service. And DMS doesn't yet support MongoDB 4.0 as a source. So we're going to have to think carefully about, if you're on a 4.0 source, maybe we're having to look at different migration options in order to get you to DocDB. So if, like many customers we talk to, you're on an older version of Mongo, something in the late 2 or early 3x version family, you're going to need to upgrade your sources before you can migrate to DocumentDB. This also, by the way, has implications for your driver version, and typically customers who need to upgrade their sources before migration also need to upgrade their drivers. The nice thing is that the newest driver for basically all supported languages also tends to support a number of versions going backward. So it doesn't necessarily mean that you have to use something other than the latest driver to use DocumentDB. So there are some functional differences that exist between MongoDB and DocumentDB. So one of the ones to note is that DocumentDB changes to a single collection are implicitly transactional. So this means that if you update a number of documents in a single query, they're all going to update or fail as a unit. It is implicitly transactional. So DocumentDB doesn't order results by default like Mongo does, so you have to use an explicit sort on your queries. Some other examples, are the fact that we don't support dots and field names yet. And if you use certain kinds of indexes like sparse indexes, we have some requirements around the way that your queries work in order to use those. And it's worth pointing out, just to take a quick look, these functional differences are all listed in our documentation. And so you're able maybe to get some better information with examples here about what these functional differences might be. And we also cover some things that have changed. So some functional differences that maybe existed in the past and don't anymore, for example, are the fact that DocumentDB now supports role-based access control. We've improved our support for multi-key indexes. Those are indexes with arrays. And then we pretty extensively cover all of the things you may want to think about from a functional difference perspective. So next, we want to think about the service limits in DocumentDB. And so our limits are different than MongoDB. And of course, it's important to understand the limits of any database that you use so you make sure that you can, work within the limits that you have. So one of the most important limits that you're going to want to know about is the connection limits on a per instance type with DocumentDB. So we have a connection limit that varies depending on the instance size. So for instance, our R5 large family, it could be about 1,100 connections per instance is the limit, up to about 4,500 connections per instance at our larger instance sizes, like our R5 12x large and larger. So one of the things that you'll want to know if you're considering a migration from Mongo to DocDB is to take a look at what your connection usage is today and understand how that relates to what the limits are. One thing that we often talk to customers about is if you have an architecture for your applications that deploys, for instance, with microservices, maybe use Kubernetes and containers, and you have a large number of connections that are created because you have a lot of workers that each have their own connection pool. So often what we find is that just going in and making some changes to the configuration files for the connection pooling for those workers is sufficient to bring you back within DocumentDB service limits if that's necessary. And so we also talk about these limits in our documentation here. And we pretty extensively cover limits from a regional perspective, not just the regions we support. We have quotas on, of course, across a region for what you can have in terms of the number of clusters and so forth. But also some of those individual cluster limits, like I was just talking about, understanding that, that we have a 64 terabyte limit on the amount of data that you could have in a single cluster, the number of connections on a per instance basis, and so forth. And here are those instance limits that I was describing before. So this is all available in our docs. So
hey Jeff,
most customers,
which might be worth answering. Is it mandatory to upgrade the source MongoDB cluster to 3.6 before migrating to DocumentDB?
Sure, good question. Thank you. So the answer is that it is mandatory if you want to use the AWS tools like DMS in a supported fashion, right? So it is true that DMS, for instance, may work with other versions of MongoDB as a source to DocumentDB just fine. However, those versions have not been as extensively tested and vetted, and so are not officially supported from the AWS perspective. It's also worth noting that there are certain migration options that we'll talk about in a little bit, such as a simple dump and restore, and those may work just fine with older versions of MongoDB to get the data into DocumentDB, because while the feature set and wire protocol may have changed between those versions, the output from tools like MongoDump and MongoRestore may work just fine.
Sounds good.
So when we're thinking again about compatibility, we're often talking about which APIs DocumentDB supports. I said before that we're not a drop-in replacement for MongoDB, and what that means is that while we support most APIs that customers want to use today, we don't have all of them. And so we have most of the data, all of the basic CRUD operations, your inserts and updates and deletes. Of course, those are supported well. Most of the database commands are supported. We do support the aggregation pipeline, and we support a large number of stages and operators in the ag pipeline. But we publish very clearly all of the different APIs operations in MongoDB data types that are and are not supported in DocumentDB. And so if you take a look here at this at the documentation, we can see that, for instance, we'll show you not only whether or not it's a straight yes or no if we support a feature that you might want, but we even have noted that as DocumentDB has grown and we've continued to add support for features, we show you when we have done so. For instance, role-based access control launching in March of this year. So it's important to take a look at your applications and understand, if there are APIs that for a fact are crucial to your application's use case. It's very easy to go look, of course, at our documentation and understand whether or not we support that. But at the end of the day, there's absolutely no substitute for testing your application. You need to make sure that you're going to take a representative workload and run it against DocumentDB in order to understand whether or not we cover the fullness of all of the features that you need. So when we're thinking about our migration options, the type of source deployment of MongoDB is very important. So we can have MongoDB deployed as a standalone that is basically like a single process that's running on a server somewhere. And this is, a pretty common implementation that you'll see for dev test environments, not so much for production typically. But if you have a standalone and you want to use tools like DMS to migrate data to DocumentDB, you have to convert it to a replica set because it needs to have something called the operations log or the op log in order for DMS to read the source for change data capture. And so the conversion is very simple. It's a single command, rs.initiate, that will convert that to a replica set. So if you have a replica set, you know what I've been talking about already. This is most often deployed as a 3-node replica set where typically one node is going to be the primary and you'll have, typically a couple of nodes be the secondaries. And so it's pretty common to use one of those secondaries as a source for DMS for change data capture from the op. Finally, you can migrate to DocumentDB from a sharded cluster, and effectively what you're doing then is migrating your shards in parallel. It is more or less the same approach as migrating a single replica set, with the exception, of course, that you're going to have to do it multiple times in parallel because it's multiple replica sets, one per shard. So as I was pointing out, we extensively have in our documentation support for all of these different things that I've discussed, and including some things that I'm going to talk about in a moment. So please, take a look at the docs, and hopefully we have in here the information that you need in order to do your planning and discovery. So from a sizing and costing perspective, what you're going to want to know about your source deployment is it's going to start with sort of the metrics associated with it. And in DocumentDB, we are thinking about, what are your read and write requirements? How many writes per second do you do on average? And if you have a bursty workload, what does that burst up to in terms of peak? And how often do you sit at your peak rate throughput? the same question is going to be asked about reads. And the reason for these is because, as we'll talk about in a bit, DocumentDB's pricing model includes I/O. And so you're going, in order to have a good costing model, you want to understand what your I/O usage is going to be. So to get this information, if you're not already using some kind of system to instrument and track your MongoDB source, you can simply use tools like MongoStats, or you can go in and even instrument your own sort of process to go and take a look at maybe the output of service status with the op counters. The op counters are this monotonically increasing count of how many times a particular operation has happened since the last reboot on a MongoDB instance. And so you can take the sum of the queries and get mores, and that's basically your read traffic. And you can take the sum of inserts, updates, and deletes, which is basically your write traffic. And if you track that over time, you'll be able to understand what those writes and reads per second that you're looking for are. So it's real important to understand what your data characteristics are. And that means understanding, what does your average document size look like? And now this number is going to differ among collections. And so, there is some amount of kind of interpolation or averaging when we're thinking about these numbers to appropriately estimate what your costs will be on DocumentDB. But I find that most customers have workloads that are fairly similar when it comes to what's within a specific database. So understanding, is your average document size, 1 kilobyte or 500 kilobytes will help you make some good estimations for I/O utilization. Of course, understanding your data footprint, because of course one of DocumentDB's pricing dimensions is data on disk. And we're going to want to know both what that data footprint is today in gigabytes or terabytes, and also what our expected growth is on a monthly basis. If we get good numbers, you should be able to see with some simple arithmetic your read, or your write capacities match up with your data percent growth month over month, and hopefully give you a good sense of how your utilization and therefore your bill can potentially grow. So data management and how you are maintaining your data sizes is important to understand. And this is first from a backup perspective, and thinking about what your recovery point objective is going to be. How long in the past do you need to be able to restore from in order to meet whatever your backup and recovery requirements are? And thinking about retention policies. Virtually all customers I talk to have to have some data management process in place so their data doesn't just grow endlessly. And, this is in various different forms: batch jobs, processes that go in and delete, TTL indexes. Understanding what those data management processes are today is important because, you may want to decide to use a different data management process after migrating to DocDB. So this is how you can gather some of these characteristics, some example commands, and these are easy to find, in our documentation. But you could go and find out, what is my average document size over a specific database, and how much data am I using in gigabytes as a footprint? What does my growth look like on a monthly basis? So we offer a 1 to 35-day point-in-time recovery window with DocumentDB's backup facilities, and so your recovery point objective should translate to that for at least recovery down to the second. Now, you can, of course, using our snapshot facilities, have RPOs that go much farther back in the past than 35 days, but those will be not point-in-time to the second recoveries, of course, but consistent to whenever you took that specific snapshot. And what we find most customers have is that something between 1 and 35 days tends to work pretty well for the I need to recover to this particular second in time use case. And then potentially they'll take manual snapshots, every week or once a month to have sort of a long-term backup strategy for, maybe they want to go look at some data that was rotated off last year. So that data retention strategy is going to be important when you consider DocumentDB's I/O pricing model. So customers who are using TTL indexes to delete large amounts of data on a regular basis, I think we'll find that you'll be happier if you change to a management strategy, like, for instance, populating collections based on time and then just dropping those collections when you no longer need the data. And the reason why is that while DocumentDB supports TTL deletes, the TTL delete process incurs I/O utilization. it uses I/O to go retrieve a document and delete it, but dropping a collection is essentially free. So if you tend to rotate through large amounts of data, this is something that should go into your migration planning process. So when we're thinking about the planning phase of your migration, we have three basic things that we're trying to accomplish. And the first is, again, to determine what should your cluster requirements be for the DocumentDB cluster that you're migrating to. The second is going to be to select the migration approach that's going to work best for your combination of requirements. And then finally, we want to see a detailed test plan created and tested to help you through your migration. So figuring out your cluster requirements in part depends on understanding what your availability target is. DocumentDB offers configurations that have availability goals between 2 and 4 nines of availability. And these depend mostly on the number of instances that you have deployed across availability zones for your DocumentDB cluster. DocumentDB's architecture separates storage and compute. Our storage cluster is responsible for the durability of your data, and the instances provide availability and access to your data itself. And so when we deploy only one instance in your DocumentDB cluster, we're going to achieve a 2 nines availability goal. This also impacts potential recovery times, by the way. So a single instance DocumentDB cluster where the instance becomes unavailable due to, say, some underlying hardware failure will take typically 8 to 10 minutes to come back up to availability again, because we have to go through the process of deploying a completely new instance in the DocumentDB cluster for you to access your cluster with. Now, if we have more than one instance, if we have 2 or more instances, one of the instances at least is going to act as a replica. DocumentDB supports automated failover to replicas when a replica exists, and that process takes roughly 30 seconds or less. So you can see there's a pretty significant difference in terms of the availability from a failover perspective between choosing to deploy only a single instance and 2 or more. With 3 instances across 3 availability zones, we can offer up to 4 nines of availability. You can have up to actually 15 read replicas in DocumentDB, but you don't gain any additional availability past 3 instances. So from a performance perspective, there are 2 primary things we're going to want to consider. The first is the CPU power available to your applications on a per instance basis. And CPU is used for things like sorting result sets, updating indexes, and so forth. And so, of course, they're important for both, your DocumentDB primary and any read replicas you might have. So it is important to think about what level of concurrency that you need to drive your database and choose an instance that's going to have an appropriate amount of CPU power. The other component, which is crucial in considering instance size, is the available memory. And the available memory is important because it defines how much working set cache is available to your instance. And so you get roughly 2/3 of your memory as working set cache. We want your indexes, for instance, to fit in memory, and so choosing an instance class based on the amount of availability or available memory is a good idea. So when we're thinking about actually accomplishing a migration to DocumentDB, there are 3 basic approaches that we want to take. The first approach here is called the offline approach, and that's because it's a simple dump and restore. And so as you can see, you start by just stopping writes to your MongoDB source, and then we'll typically use the MongoDump tool to dump data and indexes to some intermediate location. In this case, I'm showing an EC2 instance as our destination because that's a very common way to do it. And then we want you to pre-create your indexes on DocumentDB whenever possible. The reason for this is because DocumentDB index builds are single-threaded. But when you're restoring data to a DocumentDB cluster in parallel and that index is already defined, that also means that the index is updated in parallel. And so you can take advantage of parallelism to get your index populated much more quickly than if you built it after the fact. Now, of course, you can, if you choose to build your indexes after the fact, do so. You're just going to have to wait a little bit longer for them to build than if you had pre-created. So it's worth noting that the Mongo restore tool doesn't offer an option to restore indexes first. It It only offers the option by default to build an index after the fact or to not build indexes at all. And so to address this problem, we've created a tool called the DocumentDB Index tool. And this tool allows you to do what I've just described, to go ahead and look at a MongoDB directory or a GitHub repo or a running MongoDB and extract indexes from a running MongoDB or that MongoDB directory and restore them to DocumentDB before you restore your data. The DocumentDB index tool also has some other functionality. It's capable of checking for yet unsupported version or index types and collection name lengths and so forth. It is implemented in Python. It's a fairly straightforward command line tool that has a lot, number of switches that you supply data to in order to run. And so we encourage you to take a look at this tool and use it when you're thinking about migrating to DocumentDB to get those indexes predefined in order to get your indexes created quicker. And so once you've potentially pre-created with the DocumentDB index tool, then you can use the Mongo restore tool to actually restore data to your DocumentDB cluster. There are some switches that you can provide to Mongo restore to change its level of parallelism. We cover this in our documentation in some detail. There's one that's most important called num workers per collection, and what this allows you to do is to say that you want so many threads to start and restore data from collections in parallel to your DocumentDB cluster. One way you can speed this process up is by having a much bigger primary on your DocumentDB cluster than you would normally use. So maybe you've discovered through your estimation process that what you need to run is an R5 4x large as your DocumentDB cluster instance size. You can create an R5.24x large as your primary instance, restore your data to it to get the fastest possible restore, and then just use the normal DocumentDB instance replacement process to then scale back down to the 4x large that you needed in order to get your data DocDB as quick as possible. And then once your data is there, you simply change the endpoint to point to your DocumentDB cluster, and you've now migrated. And so this is by far the fastest way to get data from Mongo to DocDB. It has parallelization options that aren't available to us elsewhere, but it also incurs the highest downtime because clearly you're not able to write to your database until all of these steps have been taken and you can get back up and running with your new DocumentDB cluster. But it is the simplest approach by far. You really only need to learn the standard MongoDB and Mongo restore tools, and potentially, of course, we recommend you experiment with a DocumentDB index tool as well to get more familiar. So the second approach we can consider is called the online approach. And this is an approach that is used by customers who can't tolerate the kind of downtime that I was talking about a minute ago. And so what the online approach allows you to do is to continue writing to your source database. And now you can dump and restore your indexes with the DocumentDB index tool here. And I've noted that that's optional, but it's worth noting that the database migration service does not support moving indexes on your behalf. And so if you have indexes that you need to migrate, you're going to want to use the index tool in order to move them over to your DocumentDB cluster before you start using DMS. Then we can choose to use DMS to do what we call a full load and replication mode. And so DMS has tasks, and those tasks are responsible for actually doing the job of moving data from a source to a destination. And those DMS tasks can be run in a number of different modes. And so one of the modes is called full load, and this basically just copies all of the data from the source to the DocumentDB endpoint cluster. And then it has a mode called CDC, or change data capture, replicate ongoing changes. And this is the mode that's going to read from the op log on the source and write the change data to the DocumentDB cluster. And so if you choose to run it in both modes, that is the full load plus CDC, you can continue to use your source. Those changes will be replicated over. And then when you're satisfied with the amount of delay between a write here and showing up in your DocDB cluster, you can just cut your application over to use your DocumentDB cluster, and you migrate it. Now, this is by far the slowest method of the three for migrating, and the reason why is because the database migration service is a single-threaded process today. It doesn't support any kind of parallelization for full loads from the MongoDB source to the DocDB cluster, and for larger workloads, and by larger I mean 500 gigabytes or more, a terabyte or more, this can take a while, sometimes longer than some customers are willing to live with. But it does minimize the downtime that you're having to experience in your application when you're migrating. Finally, I call this medium complexity because you have to learn a new tool in DMS and potentially the migration tool or the index tool. And so this is new information that you need to go and understand as opposed to just a simple dump and restore. So the last approach that we typically see is called the hybrid approach. And what this tries to do is to take the speed of the offline approach and marry it with the low downtime of the online approach in order to try to achieve the best of both worlds. So we'll see that you can, of course, continue to write to your source database. And you can dump your data in indexes using the MongoDump tool to an EC2 instance. Then, of course, we're hopefully going to use our DocumentDB index tool to restore those indexes to our DocumentDB cluster. We're going to use Mongo Restore to restore the data in parallel to our DocumentDB cluster to get the benefit of that extra speed. And then we're going to be able to turn on a DMS task to start replicating from our Mongo source to our DocumentDB cluster. Now, back when we executed step 2 and we dumped our data and indexes with MongoDump from our source, we're going to remember when we did that. We'll call it time T0. So that MongoDB oplog that I talked about before, which is basically a ring buffer of changes that happen to your MongoDB instance, is sized typically so you can go back in time a little bit and look at changes that happened before now. So that DMS task is capable of taking instruction to say, I want you to start replicating from this point in the past. And we would tell it in this case, start replicating from that time T0 when I dump my data in indexes, and DMS will then start replicating from this point in the past the changes to your DocumentDB cluster. Interestingly, the MongoDB oplog is idempotent, so you can actually tell the DMS task to start a little bit before you did your T0 dump and just have some overlap to ensure that you don't miss any operations at all. So because we're taking the best of both worlds, this is faster than the online approach for migration, and it still minimizes the downtime that you're going to experience when you're migrating to your DocumentDB cluster. But of course, it is by far the most complex of these three approaches because you need to understand the DocumentDB index tool, MongoDump, Mongo Restore. You need to understand DMS and how to use it, and then of course the timing that's involved, making sure that you're getting all of the data. So again, the DocumentDB index tool is linked here and should be in our documentation as well. So when we're thinking,
when you talk about using DMS, can you use DMS to migrate non-Mongo workloads to DocumentDB?
Absolutely. So DMS supports a large number of different sources and destinations. DMS is intended as sort of a general purpose data migration service. And so DMS supports sources that has been used to migrate to DocumentDB from, for example, MySQL as a replication source from a relational database to a document database in DocumentDB. Typically what it does is it'll take your column definitions and turn them into fields, and then the value of that column will be the value that you see. So you tend to get sort of a flat one-level document in DocumentDB from your row content. But yes, absolutely.
Thank you.
So when we're thinking about that sort of testing phase and getting ready to actually migrate and vetting our choices and understanding what we're going to do, there are some considerations that we want to think about, especially depending on the type of migration source. So, of course, as I've said before, we always want to create indexes whenever possible ahead of time. Mongo Restore creates them after, and it doesn't give you the option to do it before, which is why we built the index tool. And you will see a pretty significant difference in index build times if you create them ahead of time as opposed to after the fact. So if you are using either the online or hybrid approach, which depend on the MongoDB oplog on your source, you want to make sure that that oplog size is sufficient to retain all of the changes that happen between when you started your Mongo dump and when you're going to turn your DMS task on to replicate changes to DocumentDB. So the op log is it has a default size, and you can also go in and run simple commands to understand what period of time it probably covers based on your update and write rate. And it is fairly easy to change the size of the op log with simple commands in the CLI to add additional space and therefore cover additional time. So the best way to figure out what the correct size is simply to do a dry run of a migration. Once you've selected an approach, to simply walk through the steps in a test environment, to time, wall clock, how long it takes, and then give yourself a sort of healthy buffer in your op log size to set it and make it big enough for your migration requirements. So if you're migrating from sharded clusters, there are a couple of other things you're going to want to think about. So the first thing that you have to do is that you have to turn off the balancer process. This is a process that's responsible for moving data back and forth between shards and MongoDB sharded clusters. We need to disable it because if we don't, we'll get inconsistent or potentially duplicate data as we try to parallel migrate data from the individual shards. There's also a process that needs to be run on every shard to clean up what are called orphaned documents. An orphaned document is the result of a failed attempt to move data by the balancer from one shard to another. These orphaned documents effectively show up as sort of dead data, but can show up in the migration process and result in duplicate data and key errors unless we remove them ahead of time. There's a command that you can run called cleanup orphan that will remove these from a shard. This does impact performance on the sharded cluster, so it's something you're going to want to do during a period of low utilization. So the test plan is honestly the most important part of the entire migration process, and yet it's the one that I see talked about least when we engage, with customers and talk about migrations. The test plan is the thing that saves you when things don't necessarily go the way that you expected because of some timings or other issues. And so I highly encourage you, even if it's just an Excel spreadsheet, to create a detailed test plan that first starts with defining what success looks like for you. And for some customers, that might be, I have migrated this entire set of workloads to DocumentDB, within a 12-hour span. Maybe it's a specific workload you want to move off Mongo. Some applications require consolidation of several MongoDB replica sets to a single DocumentDB cluster. Whatever it is, it's important to make sure that it's documented well so everybody understands what it is you're trying to do. And then having detailed steps for each, including how long you expect it to take. This is why I always, when I talk to customers about creating test plans, they do it twice, is what we say, because you're going to add the steps, you're going to run through them, and then you can go in and fill in the expected timing because then you've learned how long it actually takes to do the things that you need to do to migrate. Setting go, no-go criteria, and this means simply saying, if I don't see a successful restore of my indexes, I can't proceed to the next step, and I need to figure out why. Figuring out how you're going to validate that you actually accomplished the previous step correctly is also really important. I, for instance, would never tell you to take my word for it that the DocumentDB index tool restored your indexes. Go log into the cluster and show the indexes and make sure they're identical to your source. Then you know that you validated that things are as they should be before you move forward. Some organizational things I've noticed is that it's super important to have an owner for each step, not just one person, but the team they're on, because sometimes people go on vacation and, you want to make sure you have someone there to reach out to. And then, of course, having a plan for what to do if it doesn't work is pretty important. Of course, we hope that this would never happen, but should something go awry in the process, understand what backing out looks like as opposed to trying to figure it out in the middle of it. So I encourage you, as part of your testing approach, of course, to test the actual application against DocumentDB before you migrate any production workloads. There is no substitute when considering compatibility for actually running the app against DocumentDB. As I've said, we support the vast majority of APIs customers use, but the vast majority is not 100%, and we want you to be confident that DocumentDB is going to serve your workload needs from the second you migrate. Telling everybody in your organization who might care that you're migrating ends up being more important than you might think. And of course, if you've run a test plan and you understand how long the migration is going to take, then you can set expectations with everyone else who is a stakeholder, and also understand yourself how to tell if you're moving along, right? So if a step that took supposed to take 15 minutes and you're into it in an hour, then we know that we want to consider where we are from a progress perspective. I also encourage you highly to share the fact that you are migrating with your AWS account teams. If you have TAMs and SAs that you're working with, please tell them both during testing and before the migration process. The TAMs and SAs in the organization also have, conduits to talk to, myself and other specialists to make sure that we can do things like, potentially help review your migration plans before you execute them, and also be around to help if you encounter problems that you don't understand. This last one is something that has come up, several times from talking to customers who had kind of a lessons learned, where when we think about migrating production workloads, we usually think about doing it at like 2 a.m. on a Sunday night, because it's the time of least impact if something goes wrong. But something that we've learned from talking to customers is that that's often not the right choice. That if you're not migrating during a time when others are around to help you and something goes wrong, then you can't get anybody to help, right? So consider who's going to be there to help you with diagnosing network connectivity issues, or permissions to execute certain commands that you thought you would be able to do if you're doing this in the middle of the day as opposed to a late weekend night. And then finally, execution is exactly what we would expect it to be, right? We're going to follow our test plan, track its progress, inform everybody who might be affected by it so no one's surprised, and understand what needs to be done. So what I'd like to do now is just to take a few moments to show you what it might look like in the console to execute an online migration by taking a look at the database migration service, kind of showing you what the console looks like and what that experience might feel like. And so let me actually start by showing you in my terminal here. I've set up a source MongoDB that I can show you databases in. And I have this database here called AppLog that is of interest. This is maybe an application log facility, and I can use this, show collections in this source database. And I have a collection called log. Let's see how many documents it has in it. Right? Counts. So I have 1,000 documents. And let's take a look at one of these. So got some information here where maybe I have an application logging facility that shows me who's used my application from where and so forth. So over on this side, I've got my DocumentDB cluster that I've already created for the sake of time. That I will go ahead and take a look at. And let's show DBs. Let's see what we've got. I've got nothing here yet because we're going to migrate a database over to it. So let's go ahead and go back to my console. And I wanted to point out that the steps that I'm taking today, and I'm not going to do every single step, but I'm going to just show you the gist of what it feels like to migrate with the online method, is also available to you in our blogs. We cover all three methods with different blogs. I believe we have all three published, or maybe it's 2 published and 1 on the way. But we talk about things like prerequisites like I did, verifying sources, and then, of course, the steps that you're going to need to accomplish, just like I talked about before, and then some coverage of using the index tool and so forth. So I encourage you to go take a look at this blog entry if this particular method interests you. And then we have our migration documentation as well, which is going to cover a lot of what I'm describing today in detail, including the things that you need to think about, the phases, how to do things like failover testing, which we highly encourage you to do. Since DocumentDB supports automated failover, it makes sense for you to try that in a dev test environment before you migrate to prod. You want to understand how your applications are going to act when a failover occurs. And then, of course, executing performance testing, right? So just because you've got a recommendation to size a cluster doesn't mean you should just accept that and move forward. You should test that production-like workload against the DocumentDB cluster, run those performance tests, make sure you're getting the performance you expect. So what my setup looks like here is this is the instance that happens to be running my migration source that you just saw me logged into with my console. I bring this up just to point out my security group configuration, which is something that I want to make sure that I've discussed. And then this is the DocumentDB console. And so if you haven't had a chance to look at this yet, of course, we have the clusters and the instances associated with those clusters, a number of different configuration items. Today, I'm going to be looking at our demo cluster. That's the name of it, of course. And so, by the way, you can connect to this cluster, and you just saw me do it in my console by simply copying this Mongo shell command and changing the password here to whatever your password needs to be. But from a security group perspective, I wanted to show you that I had created a security group called DB Inbound. And DB Inbound is, not the default security group. I know a lot of people like to use the default security group because it allows all to talk to all, and that's pretty easy. However, I encourage you to do a little more defense in depth and create security groups that are responsible just for your database tier. So what I've done for this particular security group is that I've allowed inbound access to the security group on the MongoDB default port, that is 27017, and I've assigned the security group to the three components of what we've used to migrate. The first component being the EC2 instance that we're going to use as our source. So you'll see DB Inbound here is covered. To my DocumentDB cluster. So if we take a look at my DocumentDB cluster, I've assigned it to here, which means my EC2 instance running Mongo will allow 27017 inbound, and my DocumentDB cluster will allow 27017 inbound. So there's one more piece that's going to need access to these and thus be part of that security group, and that's going to be our database migration service component. So this is the DMS dashboard, and is what you see if you're going to go and start to think about doing an online migration with DMS. And so DMS is comprised of a number of different components, starting with replication instances. And a replication instance in DMS is the component that's responsible for hosting the tasks, which are the processes that run to migrate your data from a source to a destination, in this case, DocumentDB. I choose right now to pick a T2 large instance size for DMS. Of course, depending on how much data you're moving and the velocity with which you need to move it, you may choose a different instance size. It's also worth noting that the many different sizes in DMS are free for up to 6 months to migrate data to DocumentDB if you're migrating to DocumentDB. So I've created my replication instance ahead of time for the sake of speed. And the next thing I needed to do is to go and create endpoints. And a DMS instance task need 2 endpoints to migrate data. Let's go ahead and create both of them. We're going to start with the source endpoint. And the source, remember, is my MongoDB instance that's running on my EC2 instance. And we're going to call this migration source together. And the engine that we're going to migrate from is going to be MongoDB. Now for server name, I need to go back and look at my EC2 instance here. So I'm going to click around a little bit. I'm going to find its internal host name right here. Then I'm going to go back over to this and plug that in. The thing that we're listening on for my MongoDB instance, we're going to run on default 7017, and I'm not using TLS on my source. I'm going to on my DocumentDB cluster, so we'll talk about how to do that. So from an authentication perspective, authenticate, and the username that I've used, I'm pretty sure is, get this right, we'll authenticate against the admin database. That's important. So one of the things, and when you're migrating DMS or from Mongo to DocDB with DMS, is that the endpoints are specific to, so it means is that if you're migrating a number of databases from MongoDB to DocumentDB, you're going to have to create a number of endpoints to accomplish this. And now the process will move all of the collections within a specific data to work to do multiple databases at once. It's worth noting that everything I'm doing in the console can also be done. A large number of these, it is definitely possible. You can also use the MongoDB the AWS APIs and CLIs to do that. Next to my source endpoints, I'm going to go ahead and test it by hitting run test on my test instance. And remember, this test instance has that DB inbound security group applied to it, so it should be able to connect to on that port. So we'll let this run for just a second. hopefully come out with some success. So what this is doing behind the scenes is basically firing up a sort of dummy task behind the scenes that's going to create this endpoint, connect to my source MongoDB, and then just make sure that I can authenticate and log in with the credentials that I've given it in order to accomplish the goal. Just to finish, and we were successful, which is great. So we can go ahead and now click on endpoints and see that I've got my migration source endpoint act. The time to go create my destination endpoints. Here, start by creating an endpoint. We're going to do a target this time because we're migrating data to it. We're going to put rest. And when we choose the engine, we're going to pick DocDB as the engine we're migrating to. Now, I need to have my DocumentDB cluster endpoint as the server name in here. So I'm going to go back to my DocumentDB console. And this right here is my cluster endpoint. But if you're not sure how to pick that out of that, we can look at configuration here and just go look at our cluster endpoint, which is listed by itself in our configurations and status. So I'll go ahead and copy that back over to my DMS, and I'm going to paste that in. Again, we have DocumentDB listing on the default 27017 port. And in this case, I'm going to enable TLS. And I'm going to do this because DocumentDB enables encryption in transit through TLS by default. Now, DocumentDB requires that you use the AWS certificate authority file to do your certificate validation against DocumentDB. This is done because we create those certificates basically on the fly when we stand up instances. And so it's going to require that you do a couple steps I've already done for the sake of time here. And what that is that you're going to need to download the AWS CA cert in order to connect to your DocumentDB cluster. And we could talk about how to do that by taking a look at this connectivity and security. We've provided some convenient links at the top here. And if you just click on this connecting programmatically link, not only do we talk about how to connect to DocDB with TLS enabled, we show you with a number of different programming languages how to use that CA file that we're asking you to download here, this RDS combined CA bundle, and then use it within your application to connect to DocumentDB. Now, in this case, I want to connect from the database migration service, and so what I'm going to do is to use the CA certificate I've already uploaded. You can go ahead and download that if this hasn't happened before. Hit the add new, upload the bundle file. It'll work the same way. I've just done this to save a little time. So let us see if I can remember the credentials of my DocumentDB cluster. Again, I want to migrate to Apple. So now that we have all that configured, VPC, and we're going to use that test instance again. Remember, this has that security group, which has the 27017 inbound. So let's go ahead and run our test. And hopefully, very quickly, it will come back and respond with success. And the success will then tell us that my instance for my replication is going to be able to connect to both my MongoDB source and my DocumentDB destination.
Hey Jeff, while the test is running, does the replication instance have to be in the same VPC as your DocumentDB cluster?
So technically, no. It is possible to migrate to DocumentDB from one VPC to another using the VPC peering functionality. And security groups can be used across VPCs as well. So all of the same things I've done here can be done with VPC peering. But it is worth noting that VPC peering does come with a pricing implication because there is a bandwidth cost for bandwidth that crosses a VPC peer. So just important. We can see that we have a successful test, and if we go up and take a look, we're going to have two active endpoints, one for our migration source and one for our DocumentDB destination. So now I'm going to go ahead and create a migration task, and this is the process that's responsible for moving data from my DocumentDB source or my MongoDB source to my DocumentDB destination. So I'll create this task, and let's call it migration task. Then I'm going to choose a replication instance. This will be my test instance that I've created before. And then my source endpoint, my my DocumentDB destination endpoint. And so the migration type, as I said before, we've got three options rather. This will simply just copy the data from the database that I've selected to DocumentDB and end, and then it'll stop because it's succeeded. So this will migrate all of the data and copy it, and then it'll tail the omp log in order to make all the changes that show up and apply them to DocumentDB. And so what this essentially ends up equating to is that online migration that I talked about, the second option. This third option of replicating data changes only is that sixth step in the hybrid approach that I talked about, where we're going to use MongoDump and restore to actually move the data, and then use DMS here to just replicate the changes. For today's use, we're going to just go ahead and do sort of the online approach and migrate existing data and replicate changes. And of course, we want to start task on create. You can choose to drop the sort or dest collections and tables if you like when you start. I don't want it to stop after the full load completes because we want to see new changes show up in our DocumentDB destination. I'm going to skip validation and logs for time's sake here. So you have to add a rule for what data to copy here in DMS. And so what I'm going to do is leave wildcards. And really from a MongoDB to DocumentDB migration perspective, what this is really showing us is just what collections am I going to move from my source to my destination. So this will give you the ability to maybe enter something different in if you only wanted to move one collection out of a number, and we'll include those, right? So we're going to go ahead and finish and create this task. We're going to watch its status, and we're going to want the status to change from creating to started, at which time this task should be copying those 1,000 app log database and log collection documents over to our DocumentDB cluster. So sometimes these tasks can take a little bit to start. And so the other thing that I noted was it wasn't the starting point that made DMS a little bit slower than a dump and restore, but rather the speed with which it actually starts moving that data for that full load. Behind the scenes, what this is running is essentially a single threaded process, which itself then obviously can basically just full load collections and read them one at a time. It's not parallel, and that means that that it's going to take a little while if you have a very large amount of data. And so while this is starting, let's go over to our console, and this is our Mongo source again, right? We're going to refresh and remind ourselves that we have 1,000 documents in our source collection. So in our DocDB cluster, if we show databases again, now our AppLog database has appeared because DMS has gone ahead and started to migrate the data across to DocDB. So if I now use this new AppLog and I show collections, right, I see my log entry, and then this is a special collection, AWS DMS apply exceptions, that will have entries if something goes wrong during the migration. If for some reason it can't move some data, then you'll see entries in here that hopefully explain why. But let's go ahead and see how many documents have been migrated over to our DocDB cluster. And it's all 1,000 documents have made it from my DMS source to my DocumentDB cluster. And you can actually go and take a look at our DMS console. We can take a look at this task, right? And we can see it says load complete, and now it's just reading the op log to move data over to DocumentDB. And if we go and maybe take a look at the statistics, we can see that it says our table has completed and that we've moved 1,000 rows from the source to the destination, which is exactly what we just saw. Now, finally, I'd just like to take a moment to say, what happens then if I write to this collection after we're replicating changes to the op log? And so let's insert a document in here, very simple one, maybe where we say x is equal to 1 into our collection. Then let's do another count, and now we have 1,001 documents, right? And so if we go over to our DocumentDB cluster, let's take a look at the count again. We now see 1,001 documents because DMS has read the op log and migrated this document over here. And we can prove this by doing a find for that document. We want to see x is equal to 1, and there we are. So we can see that that DMS has gone ahead and will continue to move data from this database, from our source to our collection as it's written, which sort of forms the basis of how we're going to do our online migration. We would finish this process then by when we hit a point where we were satisfied with the state of the data on DocumentDB. Maybe we let this run all day. We have a period of very low utilization that happens, in the middle of the night. That's the time that we decide, okay, now it's time to cut over to my DocumentDB cluster, and then I would simply go and change my application pointers to my DocumentDB cluster using, this cluster endpoint that you see here. So that's what it looks like for an online migration. I've skipped the part where I pre-created my indexes, and of course you're going to want to do that if you're actually doing an online migration on your part. But that's what it looks like for an online migration for DocumentDB.
Hey Jeff, a question. When using DMS to migrate from Mongo to DocumentDB, are there any recommendations or best practices when it comes to speeding up performance that you would recommend?
Sure. I think the most important thing from a DMS perspective is making sure that the selection of both the instance size that you've chosen and your DocumentDB primary are going to be big enough to allow you to max out the throughput, right? So if we took a look at the replication instance that I selected here, so this is just the DMS T2 large, and this is a fairly small instance from a throughput and power perspective, right? But if we looked at, for instance, what it looked like to create a replication instance, you can choose an instance class, and they go all the way from T2 micro to R4 8x large. Now, because this process is single-threaded, there is going to become a point past which either a larger DocumentDB primary or a larger replication instance for DMS is probably not going to buy you very much. However, it's likely that going a little bit bigger than a T2 instance will probably give you some additional throughput when it comes to migrating the data.
Sounds good.
All right. Well, great. Well, that's what I had for today's session. If we don't have any additional questions, happy to cover what's in the chat session. Pete, do you have anything else we want to talk about with respect to the migrations? And I'd also like to point out, since we had our documentation up, that thinking about getting familiar with the tools and the command line utilities that exist is an important thing to understand as well. One thing I'll just point out, since this was a conversation that I had earlier this week that was kind of interesting. For a migration that's not coming from Mongo, we were talking to a customer that was migrating from Couchbase, and they were like, what does that look like? How do we do it? And what becomes interesting is that for the non-DMS supported sources, it's not as easy to execute an online migration process where you have that minimum downtime, but the actual migration of the data from an offline dump and restore turned out to be almost as simple as dumping all of the data to disk, running a script to remove any periods and key names, and using the Mongo import tool to import it into DocDB. So MongoDump and Mongo Restore export data in binary and format, and then restore it from that binary, what's called BSON format, to DocumentDB. Mongo Export can export data from Mongo or DocDB into TSV, CSV, or JSON format, and it's also capable of importing from those formats with the Mongo import tool. And so that ends up being a lot of flexibility, where it turns out that virtually every data store can export data in one of those formats, and so it's possible to get it into.
So one of the other questions is, you mentioned the 6 months of free DMS. Is that something customers have to do special to get access to? How can a customer get access to the 6 months free DMS?
Yeah, so you don't need to do anything special at all. The free DMS is based on what you're migrating to. So there are a number of different services that are eligible as targets for the database migration service free tier program. DocumentDB is one of those, so you're covered there. The only other thing is that it's only a certain number of instance classes for within the free tier that is covered. And I believe it's C4 large and below are the ones that are in the free tier for the database migration service. So it's certainly true that we talk to a lot of customers who are able to migrate small to medium workloads and don't pay anything for DMS at all to accomplish it.
Sounds good. So I think you covered this a little bit. When should one use MongoDump, MongoRestore versus DMS? Do you have any examples from case studies or any other customers you worked with that you'd like to share?
Yeah, so going back to my presentation, the key things to think about, just to go way back to our approaches, we're really thinking about comparing these three, considerations on the right-hand side here. What is most important to me? Is it to move as quickly as possible and the downtime doesn't really matter? MongoDump and MongoRestore are going to be the tools of choice in that approach because you can maximize a lot of different options in order to get your data through as fast as possible. So you can try to use an EC2 instance with a faster disk in order to maximize that throughput. Maybe an NVMe instance. You can make sure that you are maximizing the size of your DocumentDB cluster and maximizing the MongoRestore switches that you're using in order to parallelize as much as possible. By the way, and I think we have this in our docs, my recommendation is if you're taking this approach, there is a switch called num workers per collection for MongoRestore. Set that to the same number of cores as exist on your primary instance as a starting point. I found that works quite well. So our largest DocumentDB primary instance, an R5 24x large, has 96 cores. And so you can then set your MongoRestore num workers per collection to 96, and you'll get some fairly fast performance in restoring those. Now, to compare that to the online, and this is the using DMS, this is when you care a lot about minimizing the downtime, and it's okay if it takes a little longer. And as I said, most customers 500 gigabytes and under for data set size they're not concerned about the speed. They're perfectly happy with its performance. It's when we start getting into the multiple terabytes of data that you're going to want to think about, using a MongoDump and MongoRestore or using them in conjunction with the.
Got it. Makes sense. There's another question. So in your demo, you showed how to migrate a Mongo instance hosted on EC2. Can you show the steps or talk about the steps for how one can migrate a standalone Mongo instance outside of AWS? So someone hosting it on premises or in another cloud?
Yeah, we can certainly talk through it. I don't think we quite have time to set up the connectivity, but really the big difference between those is going to be, as you've said, the connectivity to your MongoDB source. So let's look at the offline approach, for example, to start with. So if you're just using offline and you're just using dump and restore, you have a little bit of flexibility because, for instance, you could take this dump, intermediate source, and that could even live on premise. So maybe you fire up a local instance and you do a MongoDump locally, then you can copy to maybe an EC2 instance in your VPC and then do MongoRestore to your DocumentDB cluster. This is typically the approach for offline customers take from on-premise sources simply because it's a little bit less complex to set up the connectivity from your VPC to your on-premise source. So really the SCP could be as simple as rsync or SCP to push data up to your VPC. Now, if you want to make use of DMS, if you want to do the online style approach, then we're going to want to think about the connectivity options between your on-premise and your VPC. And this ends up not actually being really DocumentDB specific. So the two primary methods that customers use to connect online premises to a VPC are to either use a VPN. And so all AWS VPCs have as an option the VPN gateways that can allow you to connect your local on-premise VPN to your VPC and use that as a connectivity point to migrate data across. Set up properly with the correct routing in place, then your DMS task will be able to communicate with a Mongo source that's not in the VPC, but outside the VPC on your premise by communicating over that VPN. One other thing worth considering is that if you're migrating very large data sets, and by very large I'm talking terabytes, right? Terabytes and larger, then sometimes VPN connectivity in terms of the bandwidth and speed that you accomplish is not sufficient. And so AWS offers a service called Direct Connect, which is a direct fiber connection from AWS, either your VPC directly or the AWS backbone, to your on-premise. So what we see a lot of customers who are migrating a lot of databases or who are migrating very large databases to DocumentDB will do is to set up a direct connect connection between their VPC and their on-premise and then migrate over direct connect to DocumentDB. And the advantage of using direct connect over a VPN is that it's typically much more reliable. It is typically much more performant from a throughput perspective. And then it also tends not to suffer from network issues like jitter and excessive latency, which are, of course, important to a migration.
Makes sense. Thanks. So for folks who are still on the webinar, if you guys have any more questions, feel free to drop them in the Q&A window. I think we still have a few minutes, so we'll be more than happy to cover them.
Yeah, and I wanted to make sure while we just had a minute or two to talk about some of the aspects of our documentation for DocumentDB, which are important not even just for thinking about migration, but for using the service effectively. We strive to hopefully put the stuff that's useful up at the top in order to make it easy for you to get to what you need to know. And so we talked about like learning about the functional differences in our service and comparing them to what you're using with your MongoDB sources, and we talked about our supported APIs and operations, which we definitely want you to take a look at. But we also have things like our best practices, so things that we want you to think about, before you migrate, because of course we don't want you to learn what the best practices are and implement them after your data is already on a DocumentDB cluster and you have production apps pointed toward it. So thinking about things like appropriate index, utilization, instance sizing being so crucial, especially with respect to that working set cache size, and then helping you understand things like data management in order to optimize your cost of your builds as small as possible. And we want to make sure that customers are doing things like using batch inserts in order to speed along, data as it's imported. We cover security and so forth, and our limits. Our limits we talked about before on the call, and these are going to be important for you to understand from a connectivity perspective. Finally, naming constraints tend to be more important than you would expect from a migration perspective for customers who have naming conventions that tend to use all of the available characters in MongoDB. So many of DocumentDB's naming constraints tend to be 1 or 2 characters shorter than Mongo, and this is something that you'll need to pay attention to if you think you're in that. This is something that's, obviously we want to make sure that you're aware of this before you try to execute a migration, so you can take a mitigation strategy like renaming your collections while they're being moved or something of that nature.
Hey Jeff, we have more questions coming in. One that just came in a couple minutes ago. For someone who's new to DocumentDB, do you have any recommendations in identifying when to use DocumentDB over, let's say, SQL Server, for someone who has SQL Server background?
Sure. And this question is really then, I think, not necessarily directly about DocumentDB versus SQL Server, but relational databases versus non-relational databases. And this really boils down to what is most important to your work. So relational databases, obviously they've been around a very long time. Most developers are pretty comfortable with them, and that's because they're really good at a large number of things. But, when your data is you can say of your data, for instance, that the schema does not tend to change very often, that you can define a data model in terms of your rows and columns, and it pretty much stays that way for a long period of time. When it's really important to you to be able to, relate your data, thus relational, from one piece of information to another, typically using things like foreign keys to enforce integrity between parts of your data. Of course, relational database is going to be very good at that. And finally, when you find that the way that you need to run and manage your database doesn't require a ton of flexibility when it comes to not only just the definitions of the data, but necessarily what might change in the future. Not now, but in the future. Relational databases meet all of those. They're very mature. They tend to have a lot of very rich tools in order to use them, and so that recommends them. Now, on the flip side, Non-relational databases tend to work very well for workloads that value flexibility. And so you'll notice that most non-relational databases, like DocumentDB is a document database, they support things like extremely flexible schemas. So it is very easy in DocumentDB, if you have some information about somebody and you want to start adding some new information tomorrow, to just add that to the document that defines that person. And there's no database administrative overhead to change that. You just put the data in. Compare that to what it looks like in a relational database. You typically have to alter table, add column in order to have that new data stored in your relational database. That has a potential performance impact on that relational database and can create a lot of churn and admin overhead if you have applications that tend to change pretty frequently with respect, to their data definitions. And also, of course, non-relational databases tend to invert the modeling that relational databases do. So rather than normalize and try to use as little storage as possible, we flip it, decide that storage is relatively cheap, and basically denormalize and have duplicate data quite frequently in exchange for performance, because it can often be faster to aggregate over lots of information with the same data than to go and to dereference references in a relational database across many tables to do the same sort of thing. So mostly it boils down to whether or not that enforcing that referential integrity on a workload that doesn't tend to change its data structure very often is relationally oriented. If you need a lot of flexibility, maybe you're writing a new app, you're not really sure what questions you're going to ask your data in 3 months, then a non-relational database like DocumentDB is a good choice.
Makes sense. I think that covers relational versus non-relational really well. As you were talking through that answer, another one came in around what's the major difference between DocumentDB and DynamoDB, specifically when to use which one?
Sure. Yeah. So DynamoDB is a great database. It is effectively a key value store with some extra good features. And I say it's effectively key value because, of course, DynamoDB works by having what we call items that have a partition key associated with them that effectively you supply that partition key whenever you want to retrieve data. And so the advantage to this is that you are able to functionally build a system under the hood that is extraordinarily performant and scales almost limitlessly. So, you can basically put as much data you want to in a Dynamo database. And regardless of the data set sizes, your key retrieval times tend to be consistent, whether you have, 50 items or 50 billion items. It's going to come back just as fast. And DynamoDB has some extra features built into it from a service perspective that are quite attractive. So things like global tables, right, where you're allowed to, have your information automatically replicated to multiple regions at once. These are all very attractive things about Dynamo. Now, on the flip side, for DocumentDB's core strength is flexibility. So whereas when you're planning how to orient your schemas and your workloads in Dynamo, you have to make some really opinionated choices up front before you structure your data and insert it into your DynamoDB tables. And DynamoDB is not very easy to change your mind about later if you want to ask different questions of your data. So contrast that with a document database like DocumentDB. It is very easy to change your mind about how you want to query your data. Ad hoc queries are very easy to do. It is, as I said before, extremely easy to go and just have different data for different documents and different data sets. When you want to add additional information into a document, you just add it and move on. And if your access patterns change, right, and this is the key thing, I think, between the two, it's easy to handle that with DocumentDB. You basically, will typically just go add an index that's going to handle your query patterns appropriately for the new data access pattern and then just sort of move on your way. Whereas with Dynamo, those opinionated decisions up front need to be very good ones when it comes from a design perspective, because it's a bit more difficult than to change what your access patterns will be and do them once your data is in there and you're using
it. Sounds good. Yeah, makes sense, Jeff. In terms of sizing and just DocumentDB versus DynamoDB, DynamoDB is serverless, while with DocumentDB you need to specify size, CPU, memory, etc.
Yep.
Are there any features or capabilities that enables DocumentDB to scale up as needed, similar to DynamoDB?
Yeah, so you're absolutely right that one super nice feature about DynamoDB is that its serverless nature coupled with the auto-scaling abilities of Dynamo let you basically just use the database, and it handles throwing the resources that it needs at the workload to handle the problem. And DocumentDB is not serverless, so you do in fact need to kind of sit and think and figure out what a good instance size is to handle your workload, both from instance size to handle the throughput needed for writes on your primary, and then potentially how many read replicas you need to handle the read workload. When it comes to, you know, if the question is, can I auto scale on DocumentDB? And the answer is no, or at least not yet. So you absolutely have to take action in order to change your DocumentDB cluster's configuration to change thus the scale that you can handle. Now that said, there are ways that you can effectively build your own auto-scaling system for DocumentDB without too much trouble. So AWS has a service called the Application Auto-Scaling Service, which is named similarly to but different from the AWS Auto-Scaling Service. And what it allows you to do is to define a CloudWatch metric of your choice. For DocumentDB, you might choose CPU utilization over time or buffer cache hit ratio or something similar, and then write two Lambda functions that are able to query the state of your DocumentDB cluster and then change that state by maybe adding and removing read replicas. And the application auto-scaling service handles all the rest of the work of creating that tracked CloudWatch metrics, stuff, and running the code to say, okay, when that metric triggers an alarm to go take action by scaling my DocumentDB cluster up and down. So it is possible to build a system like that. It just doesn't exist in the DocumentDB engine yet today.
Makes sense. Another question that's come up are what are some unique capabilities of DocumentDB?
Yeah, I think the most unique thing about DocumentDB is its architecture. So DocumentDB's architecture separates our storage and our compute. We have an intelligent storage volume which is responsible for the durability of your data. When data is written to it, the volume is responsible for writing your data 6 copies across 3 availability zones, and it essentially is responsible for serving up database information on demand from the instances as they ask for it. So one of the nice advantages that you get from having this separation of storage and compute with our instances and our cluster volume is that it is extremely easy to scale up and down, especially with respect to read capacity, and it's very fast. So DocumentDB's instances aren't data bearing, which means that if I want to add more, I don't have to wait for data to copy from one instance to another. And what that effectively means is that I can have a 20 terabyte database that I can add read capacity to in 8 to 10 minutes, which is not true of virtually every other traditional database architecture out there, because all of them depend on copying data around to change their scale posture. So so reads, we can scale DocumentDB just by adding and removing read replicas. We scale writes vertically, so you've got to make your instances bigger and smaller. But since the service is fully managed and we do that on your behalf, what it truly amounts to typically is standing up some instances, hitting the failover button, and then you've scaled up for your writes in a matter of a few minutes, which is still not the case for other database systems.
Makes sense. Thanks, Jeff. We'll probably take a couple more. Another question that's out there, what are some benefits of moving a self-hosted MongoDB database to a fully managed DocumentDB cluster?
Yeah. So I think the obvious clear win is the lack of administrative overhead. Virtually all of the customers that we talk to who are interested in migrating to DocumentDB are doing so because they want to get out of the business of managing databases. They want to focus on, writing code that does whatever it is that their business does, delivering food or giving people rides or what have you, and not, worrying about hiring people just to manage the database and do nothing else. So the most common use case that we see is a customer who says, I want the person who's responsible for managing this database and also writing code just to be writing code. And so when you migrate from self-hosted to DocumentDB, all of a sudden deploying is our responsibility, right? patching and upgrading, that's our responsibility. And then on top of that, you get the advantages of all of the integration with AWS services that come with running a managed AWS service. And so, you get built in the monitoring and alarming with CloudWatch metrics, and you get built in the auditing capabilities in CloudTrail, all of which you would have to build yourself if you were self-hosting a database.
Makes sense. Thanks, Jeff. I think we've answered pretty much all the questions from the Q&A. Thank you, everyone, for taking time to chat